first things first, the community has matured, right? It's the point where now you can build practical applications in any technology you want. And obviously I'm a big proponent of Spring, hence the t-shirt. So I've got a couple of microservices here that we can look at. They're just trivial little microservices. One of these is a customer's endpoint. It's an HTTP service that returns customer data. So it's a record. It has a field called ID and a name.
Yeah, but what's cool in this example is that it's now just become easy to do the right thing, which is to be reactive, to not waste resources if we don't have to. And so using that reactive CRUD repository with a reactive controller that returns a flux, it's just now easy. And every developer can now easily be reactive. And that's what's cool.
Right. And it's familiar. The only telltale sign that we're doing something reactive as opposed to not reactive is we're returning a flux and we're using the reactive code repository. Otherwise, this is exactly what you would have written using traditional blocking imperative IO. But it's better, Okay, so I've got some data in the database. I created a schema.sql to create a table called customer with a primary key and a name of our car. And then I created data.sql and put both of these files in my source main resources folder. And they just insert some records into the database. Of course, guests first. So I'll put you first. So, okay. So that's up and running. And this endpoint, I went to start that Spring.io. I've got the R2DBC support, which is a reactive relational database connectivity abstraction. So if you want to do reactive SQL today, the best bet is R2DBC because it connects to there's a driver, a reactive non-blocking driver for every technology you can, every database you can imagine wanting to talk to. And I'm using the embedded H2 implementation. So that's up and running on port 8080. Okay, so you can see that here, port 8080. Okay, let's just restart it. All
right. So this is reactive all the way down from the requests that come in all the way to the database. And that's great because why be reactive if you can't do it everywhere? There's just not as much benefit.
We need another system. We need, in order for this to be a little bit more fun, it helps to have things to play with, So we've got a customer endpoint. For each customer, they're going to have a profile, which is their, maybe their name, their registration date, their Twitter information, and so on. So to describe that, we've got a profiles service. Okay. And this service is using RSocket. RSocket was created by engineers at Facebook and Netflix, and it was designed to solve some of the substantial limitations of HTTP 1.x, HTTP 2.x, and gRPC. The whole point of RSocket is to provide a binary protocol that surfaces the reactive streams as part of the network protocol itself. So it reifies or makes real the concepts of reactive streams on the wire. And it was actually built in part by RxJava founder Ben Christensen, right? So it's a very interesting protocol, and I'm a big fan. But obviously, I'm a big fan. I'm wearing the Spring T-shirt and so on. But you don't have to take my word for it. There's some other small mom and pop organizations out there that are using it to great effect, including, like I said, the aforementioned Facebook, but also Alibaba, right? They're using it at scale along with Spring and Spring Boot. So this service is just a regular service. I didn't even bother with an H2 database this time. I've just used the ultimate in-memory database. Sorry, test containers. I use the ultimate in-memory database here, just a map of customer IDs.
As scalable as you can get for a database.
Right. Yeah. It's like the DevNull of DBs. DevNull DB. That's what this is basically. Okay. So var counter 0. So for each customer, and we only have 2 because it's just James and me. Then we increment the ID. We put a record in the database. Air quotes database, create a new profile, assigning it an ID, and then a date for the registration, right? And we can see that record described here. We could have other fields, but let's just keep it short and sweet. And then we create an RSocket endpoint here. I'm using message mapping. So you saw when I used HTTP, I did add controller and I used get mapping and so on. Well, for RSocket, you're dealing with messages. So we're using at message mapping, so it's not new, but it's purpose built for this kind of thing. There's an endpoint here called profiles.customer ID. So given a customer ID, that's this thing right here, we can give you the profile for that given customer, right? And we're returning it as a reactive stream. And mono is like a completable future, except it's got back pressure and it's reactive. And in that it produces at most one value. Earlier on, you saw me returning a flux, which is like a stream, except that it's reactive and it supports back pressure. But they're both ultimately publishers. Okay, so I've got my profile and I got my customer service. One's using RSocket, one's using HTTP. I think we need to build an edge service. What do you think?
Yeah, I think we should have something that takes those two services and reactively exposes both of them.
Right.
And combines them together.
Yeah.
Composes them. Composing reactive services. This is
good
cool
stuff.
I think we should do it in Kotlin.
Yeah, exactly. Kotlin's great. Obviously, I have a choice. This is the Spring Initializer, start.spring.io. You have some choices here, but they're not really choices, right? There's the choice of which version of Java you'd like to use, Java 11, 17, or 8. Obviously, among these three, you've only got two real choices, 17 or 11. And really, if you're not involved in GraalVM today, I would just stick with Java 17. So I'm going to go ahead and create a new service here. I'm going to use the reactive web support. We're going to use the same RSocket support from before. And there's one other dependency I want, right? James, you just suggested we should expose this data, right? So to the world to make it accessible. But the problem is that that data is in different forms. It comes in different shapes, right? It comes from an RSocket endpoint and it comes from an HTTP endpoint. And there's a bit of a tension here. We want small, well-isolated individual microservices, but our clients want all that data in the same payload as fast as possible without having to constantly make chatty network calls. And so rather than force each client to learn how to speak RSocket and HTTP, and rather than having to redundantly impose security on both of those, and rather than having to do the network calls all on the client, we pass everything through the edge. And the edge is kind of like a gateway to do cross-cutting kinds of network concerns. And then we have that tension of, well, we want to create a view of the data for our client. So one way we can do this is to use Reactive API. So I'll go back here to our code. All right, so we've got our basic data transfer objects. Now we need to build some code to actually talk to the downstream services. And we can't very well be expected to talk to them if we don't have a way to talk. So we're going to create some clients. Well, I use that term loosely here, don't I? I mean, I want a client for the HTTP service, but for the RSocket, well,
it's just a socket. It's both the server and a client. It's got a duality.
Yeah. So RSocket, and when you say RSB, RSocket requester dot builder equals RSB dot TCP, and with RSocket you specify the connection when you define the client. So it starts up and it connects to the service and it stays connected, and all subsequent requests are on that already connected multiplexed connection. So you don't have to reconnect. There's not the handshake, the ACK, and all that stuff. It's just faster.
And it's reactive because it's got an R at the beginning.
Yeah.
So now for our REST client, we're doing the web client, which is the reactive web client built on top of Netty.
Yep, super fast. You can use this, and you should use this for all your networking, HTTP networking needs. Okay, so there's my CRM configuration. Now I'm going to build a client, right? An actual thing that'll give us access to our data in terms of the types of that service. So we're going to say CRM client, and in order to do our work, we're going to inject into the constructor and then stash into a private field the web client and the RSocket requester. Okay, so now we can create, we have some methods here to, in Kotlin, they call them member functions, but whatever. So, okay, we're going to say we want to have a function to return.
Let's get our customers and our profiles, right?
Right, customers. Now we could do this the reactive way. We could say http.get.uri http localhost 8080 / customers retrieve .body to flux, and the return value that we expect here, remember we're going to get an HTTP JSON response. I expect that to be turned into a reactive stream of customers, and already we get some benefits by using Kotlin. I've got a member function that's returning, or that the return type is implied to be a flux of customer. But because we're using Kotlin, we have this nice type inference. So I don't need to specify the fact that I've got a flux of customer in more than one place. So I can either do it, here in the return value, or there explicitly in the terminating function. A flux is great, but it's a reactive type, and it's, in order to use it, you have to think about reactive data flow, right? You have to figure out how to chain things. There's no sort of deterministic behavior unless you use the operators in the reactive API. However, to make it easier for people, to kind of grok what's going on and to be able to think in the sort of imperative step 1, step 2, step 3 style to which people have become accustomed over the last 25 odd years of Java, there is coroutines, right? Or there are coroutines, and coroutines are awesome. And you can use our integration with Reactor, with these reactive types, to automatically add functions through something called extension functions in Kotlin. You can add functions to change, what you get
behavior,
from a flux to a flow. And I'll change this. So a flow is kind of like a flux, but it's a Kotlin type, right? Not the Java util concurrent flow, but the coroutines flow. And that's great for a stream of values. I don't need this anymore because it's implied by the type, pseudo reified generics there. We also want to create an endpoint here for the profile. So profile for customer ID int. And this one is the RSocket endpoint. So we'll say route profiles.cid, passing in customer ID, and the data that we expect back, we'll get it through a retrieve and await, right? So we'll say retrieve and await and profile.
So IntelliJ is telling you there that when you call that, you actually need to be in a suspend function to tell the compiler that that the thing is going to be async.
Which is super cool because it needs a context. It needs an async context. Now, Spring, as the framework, will provide that for you, but you still have to mark your code accordingly so the compiler can kind of understand what's going to happen here. And the
What's
benefit
cool about that method now, it just returns a profile.
Yeah, not a mono profile, just a profile. The same magic is still happening behind the scenes. Your method's going to
build non-blocking.
Yep. Yeah. Okay. Good.
Cool. Right. Some fancy inference there that makes it super clean.
Super clean. All right. Now we want to compose these things. We've got an RSocket server and we've got a HTTP server. We want to get the data from both and get them into the same view for our client. Like, again, the very common use case here is I've got different clients and they all have different bandwidth constraints, quirks, bugs, protocols, security, etc. So rather than forcing each client to learn about every single one of our downstream services, they go to the edge service and they get usually it's a tailor-made edge service. It's an edge service just for Android or just for iOS or just for whatever. And we can afford to build the endpoints that they need, right? So let's say suspend fun customer profile. So we need to actually build up a type of type customer profile. So we'll say customer profile. And we need to create a data type here to represent the composite of these two. Val customer on the left, val profile on the right. All right. So we say this dot customers dot map. And then each, we could use the implicit parameter here. The implicit parameter is called it, and it is automatically a pointer to type customer. You can see that hint there in the IDE, but just to be very explicit here, I'm going to name it customer. So what I've got is a pointer to the current customer. Now I want to get the profile. I'll say this dot profile for customer dot ID. Okay. And then I'm going to return a customer profile in response. So I'll say customer on the left, profile on the right, and that's it. That's the whole game right there. This is actually
each element of customers, and for those you go fetch the profile. So this is a bunch of different requests that are happening, or in the case of RSocket, messages, and they're all non-blocking. And this whole thing comes out as a giant composed non-blocking reactive operation.
Right. And I'm actually doing I'm doing scatter gather, service orchestration, and composition. Right. I'm launching many messages concurrently. But you couldn't get simpler code. I mean, this is exactly the code you want. It's very concise, and yet it's also the most performant version of the code, right? So now we need to, create an endpoint by which to consume this data. So we can do this via HTTP, certainly. So let's just create a controller here, an HTTP REST controller. We'll say class CRM REST controller, private val CRM client. Get mapping, COs, suspend fun customer profiles, this.crm.customer profiles. Okay, let's just try that one. That's our first cut, if you will. And this is going to start.
Let's set up the port.
Yeah, thank you. 8888. Good. Okay, so let's run that, see what we get. Actually, you know what? Rather than running it here, because IntelliJ doesn't love Kotlin these days, I'm not sure why. We'll just do it on the command line. So Maven Spring Boot run.
I like to have consistency between my build tool and my things that I run in my IDE. Yeah, so I just run everything from the build tool.
Yeah, makes sense. Okay, well, there we go. There it is again. I'm making as many requests as I can. You can see it's
look at that
calling.
So it's all composed together, but all those requests that just happen are async, non-blocking, reactive.
Right.
Super cool.
This is the customer data loaded first, but as the first record for the customer data arrived, we then called the profile service. Then the next record arrived, then we called the profile service again. But that didn't happen we didn't wait for the profile data for the first one to come back before we launched the profile request for the second one. So
there's no wasted block threads. It's all reactive.
Right. It's concurrent as possible, where the data flows as concise as possible as well. Okay, good. So this is great, but we've got what we have here is a custom view that we wrote for our client. Hopefully, this is what they want. This is the shape of the data that they need, and we should be fine. We should be able to go home for the weekend and enjoy. But what about next week when some new client comes along and they want a new view of the data? Now we're back to square one, and we need to build a new view. And this is exactly the tension that Facebook had in 2012. They realized that they wanted to have small, isolated, independent microservices, but their clients need all the data co-located in the same process, in the same payload as quickly as possible so that they don't have to do redundant calls across the network for people that are on their low bandwidth devices traveling through tunnels, right? And so they have a tension there. There's a conflict. The services should be well, isolated and independent and teased apart, but the clients want everything the way they want it in one shape in the same chunk. So they created GraphQL to support that. And we can do GraphQL in Spring. We can just add the Spring GraphQL support, but we don't have the Spring Initializer checkbox just yet. So you have to manually, as we did in the old days, add a dependency to your build by copying and pasting the snapshot repositories here, pasting that in there, and then going to your dependencies and just manually adding the GraphQL dependency. So GraphQL Spring Boot Starter, M3, Maven, reload. Okay, so there's our new dependency. Now we're going to create a GraphQL controller. You've seen an RSocket controller, you saw an HTTP REST controller, and now we're going to create another GraphQL controller. And it's the same annotation. People don't realize that in Spring, this annotation is actually part of the org Spring Framework stereotype package, and it doesn't imply anything about HTTP or RSockets or WebSockets, whatever. Okay, so CRM GraphQL controller, same idea, same basic arrangement. Private val CRM client. And in GraphQL, you have types, right? That you have to define. There's a schema. So it's just built in. It supports discoverability and introspection. So you create a directory here called GraphQL, and you create a file in there called schema.graphqls. And there, at the root of all your GraphQL services, you have an endpoint, and the enumerated endpoints come from the query type. And so I'm going to have an endpoint here called customer that gives me all the customer data. Well, of course, I need to have a type called customer, and it has an ID field and it has a name field. Now, I also want the customer data to have access to all the profile data, right? So we'll create a new type here, type profile, and the profile has the ID and it has the registered date. But unfortunately, while there is a built-in type for ID, there is no built-in type for date. So you have to just turn it into a string or create a scalar or something like that. But for now, we're going to have to create a resolver. Yeah. So we're going to create a scalar. We're going to create a resolver so that when somebody asks for this field on this type, a custom converter gets invoked. Okay. A resolver. And then same thing here for each customer, I want to have the profile. So I'll say profile. Now, of course, I want this all to be non-null, right? So we'll just add exclamation marks to all this stuff. And this is great for tools that will do code generation based on the schema, which is exactly what you want, right? It's, consistency across the boundaries.
Yeah, expressing nullability is great. And when we're working in Kotlin, it's great because that information gets propagated into what we're doing in Kotlin, where we have the explicit nullability support there too.
Right. So, okay, first things first, we want to create a let's say that we want to create a resolver for the registered date, okay, for the type called profile, starting kind of lowest first. So we create a handler method using schema mapping. Okay, this is from the Spring GraphQL project, and the type here is profile, and the field is the registered field. So that's the name of the function there. I'm going to inject the root profile off of which we're working here, and I'll say p.registered. Let's just do, something horrible. There you go. That's not great. You can do better. Use the simple date format or something like that, but that'll work, right? So whenever somebody has a pointer to a profile and they ask for the registered field, this handler method gets invoked. Okay, great. Now, what about our order data? Okay, well, I can do that here. I can say schema mapping.
Our customer data.
Profile data. I'm sorry. Yeah, profile. So
profile data.
For the customer type, I want to get the profile data, right? So profile, C customer, this.crm.profile for C.id, right? So suspend, as always. Good. Okay, so that's working.
Anything that's not a built-in GraphQL type needs to be mapped.
Right. And we have specialized annotations for the case of the type that's a query, because every program's going to have a query. So rather than using schema mapping, you could say type name equals query, and then fun customers, and just return this.crm.customers, right? And suspend. I could do that, but this is such a common thing. And by the way, if you wanted to, you can actually have field equals customers. You could do that if you wanted, but it's such a common thing to have a handler for a type in the query type that we have an annotation called query mapping, right? So this evaluates ultimately to schema mapping with type query, right? And the nice thing about GraphQL is it's very consistent. So I'm using query mapping. There's also mutation mappings for updates. There's a subscription mapping for long-lived updates, you got stock ticker updates or feed or whatever, that kind of stuff. And mutations are great because there's no dogma there. It's just you want to change the state in the server, you use a mutation. There's no question about whether it's post or put or options, or do you send 201 or 200 or 202? None of that. It's just mutation. That's it. You either did an update or you didn't. Okay, so COs, that's still there, right? Now we can go interrogate our GraphQL endpoint here. We can go interrogate our GraphQL endpoint here. We get this nice little, utility, this dialog here, and we can send a request. We can say query, and I get the customer data, and I want to get the ID, and I can ask for that, and that works just fine. I've got the 2 IDs and nothing more. What about the name? I want the name data. Good, there's that. Okay, what about the profile data? Okay, well, the profile data itself it's made of constituent fields. So I'll ask for the ID, and I'll ask for the registered, and I get all that back. Now, if I don't ask for registered, if I just say, give me that, I don't get it, and the resolver that we created to handle that conversion doesn't get invoked. So you don't pay the cost for stuff you're not using. If you don't want the profile data and you don't want to incur the cost of making the call to the profile service, then don't invoke it. Don't involve it, and you won't get the data back. But then again, you won't pay the cost either, right? This is great for now. So now you can use the same GraphQL endpoint to provide the overview data for your overview page, and then the details. When you click on a particular record in the search results, maybe you show the details, right? It's the same GraphQL endpoint. It's very, very consistent. And the nice thing is that GraphQL, as we support it in Spring, is reactive if you want it to be, which I do, or it supports imperative IO, but why would you do that?
Go reactive.
Yeah, do the right thing. Or go coroutines, which is best of both worlds. So great stuff, right? We've got really nice primitives in the reactive APIs to make it easy for us to express code in a way that the scheduler can then optimize for us, right? And we can avoid blocking at all turns. We then looked at Kotlin, which takes it up a notch and lets us write code in terms of coroutines, which is even cleaner, even more concise. But again, we're still getting the benefit of reactive programming, and our understanding of these concepts cognitively has helped us go from reactive streams to coroutines, and we're on the same page conceptually if we want to work with other people in other parts of the community.
Cool. Okay, I am recording my screen. Yes, I. What else do I need to do? I think I'm all good. Ready to roll?
Yes, sir.
Yeah, so it's cool to see how the ecosystem around Reactive has grown to be massive, and Reactive is just everywhere. It's a way that we kind of do everything now. And all the frameworks, languages are coming out with all sorts of different ways to support it. And I spend a lot of time in Scala. And so I use a Scala library called Zio. And we're going to now take the server that Josh has written and expose to us, that edge server through GraphQL. And that's, of course, all reactive all the way down. But now let's build a reactive client to that server that's going to consume that data and do something interesting with it. So Josh is giving me his GraphQL file that defines the graph of queries and types that I can use. And so let's go and build a client for that thing. There is a plugin that I'm using in this project that will take that GraphQL file and create the client-side stubs to interact with them. And to do that, I can just call this compile task, and compile will generate those different stubs for me. So that's going to take a minute to run because I'm doing a lot on my computer right now. Usually the Scala compiler is a lot faster than that.
Are you running Slack?
Yeah, I've got Slack actually mining some Bitcoin in the background too.
I knew it. You know. That'll get you. That'll slow things down considerably.
Okay, so let's go and create our query. And so to do that, don't worry about that compile error. That's just because it generated the files that we need to continue. So let's create our query. So I'm going to use these generated files and I'm going to query the customers. And then I can specify the fields that I want to get out of here. Let's do customer name. And let's also get the customer profile. So this is all type safe. Sometimes I'm working in like this nightly snapshot of Scala 3, which is giving me a lot of great new language features and awesome stuff, but it also means that IntelliJ is not working yet super awesome. So some of the tab completion stuff is not going to be working super well. But okay, so we're going to get a customer profile, but then we have to tell it what we want to get in the customer profile. So I can now just say profile.id. So that's my query, my GraphQL query. Now what I need to do is create a Zio application, which is going to use the Caliban library in Scala, which is the GraphQL library. And it's going to use Zio for the async non-blocking, the reactive piece of this, which is going to make the request reactive underneath the covers. And then Zio also does this great thing where it separates out the side effect, the effectful pieces of the application from the logic of the application. So when I create my value app, what I'm going to do is define the logic of my program. So what I need to do in app is I need to actually go and make a request, a GraphQL request. So let's define our request. And what it's going to be is I'm going to use the send method in Caliban. And then I'm going to take my query and I'm going to convert my query to a request and give it the server URL to connect to. So I can use the queries they're composable. So I can compose them together. But in this case, I want to kind of terminate that query or use it in a form of a request and send the request. But what send is send returns back to me as Zio. So it's not actually going to do the work. It's when I actually run it and Zio applies the environment to the logic of the program that it actually is going to end up making this request. So when I make this request, it is possible that the request fails. And so there's in a Zio, I can have an air channel that will take the failure and put it into the type system of the Zio. But I need to transform what I get back from the send method into that form. Normally, when I call the send method, I get back an either, which is either a error or a result. And so I want to transform that either into just a Zio because the Zio can essentially has an either built into it. So to do that, I'm going to call flatmap on my Zio, and I'm going to take a response, not a request, but a response. And in my response, what I'm going to do is I'm going to get create a new Zio from an either, and then I'm going to give it the response.body. Okay, so now we have a Zio that can either either succeed or fail, and based on what happens with the service. Now let's go and write our app. So for our app, we're going to do this in a for comprehension because we're dealing with async things, and those are represented through things with flat maps on them, or monads, and as they're called. And so what I'm going to do is I'm going to make my request. So I'll make my request there, and then I'm going to then use the put strlen method to print out the body to string. And then this program is going to yield no value. So I'm going to just yield a unit there. So that's my application. And let's go and run this thing and see what happens. So that's going to compile. Okay, so now let's run this thing and see what happens. We'll run it, and that will compile, and then run our client, and it will go off, make that GraphQL request, of course, reactively, and then return the response. So that's great. Looks like we got our list of James and Josh. Now let's try this a couple more times, because I actually had inserted something special into Josh's code so that randomly, when we make a call to customers, we're going to fail, because of course what he wrote was perfect and would never fail, but I needed to add some failure into this thing so that we can see what happens when it fails. So let's see if we can get lucky with our randomness and get this service to fail that ZO when we make the request. There we go. Looks like it failed. Okay, so one of the cool things that we can do with a lot of these new paradigms that are reactive is add kind of stream steps to them to change the stream, change the operations that we're doing, the reactive operations that we're doing in some way. So what I'm going to do with this request is now give it a retry. So I'm going to tell it to retry this thing, and I'm going to give it a schedule to retry with. There's lots of different schedules you can use. You can use time-based ones or count-based ones. I'm going to do exponential backoff, and I'm going to start with 100 milliseconds, and then the default factor is 2. So it's just going to back off. So now when I rerun this thing, it should never fail because I have applied this retry logic to the request ZO. And so just keep on retrying. And of course, I could set limits on how many retries at max I want to perform, that sort of thing. But we should never actually, even if I get unlucky a bunch of times, we should never actually get a failure. We should always get a result out of this thing. And so the cool thing with effect systems is that I have added this retry logic to the ZO, which is just adding more information to the application. And then the ZO runtime is what actually takes this in a non-blocking reactive way, actually does those retries and manages actually running this thing and performing the side effects. Okay, so that was just another example of using Scala and with a GraphQL client and of course reactive, but a lot of similar paradigms between what we saw here and what Josh did with Reactor and with coroutines and with RSocket. So the cool thing is that there's so much commonality now between the different ways to do reactive. And really, as people start down the happy path of programming, they enter in usually now through reactive methods in a variety of different entry points. So no matter where they're coming from, they can be reactive. Reactive is everywhere, and there's a common experience across all of them. And I think that's what's super exciting in the reactive ecosystem right now, is to see that commonality for how we do reactive programming. It just is the standard way to do things.
The sensible default, and you see the tenet behind reactive programming being embraced in small parts or in large parts by different languages, and then that perpetuates further into the ecosystem of libraries and so on. So if you don't have interoperability at the API level, you have it at the conceptual level already. And that helps you start with other people's code. You can integrate better. You can focus on the business logic that matters instead of wondering whether this thing or that thing maps one well enough to the other. Life becomes simpler when you can throw away all these different APIs, which are trying to express the same concepts, right? Now, you have got a few APIs. They're the foundation of your code. And you're able to just focus on the thing that matters, building valuable software and getting it to production.
Awesome. Well, hopefully that was helpful. I'm excited about the future of reactive and the world going reactive. So,
yep, me too. And thanks for everybody for joining.